Alrighty, here we see a question from the 2013 practice exam, and we see two nitrogen dioxide gaseous molecules reacting with a fluorine gaseous molecule, and we're making two of these NO2F gaseous molecules. So everything in the gaseous state, and it says it's proposed that the reaction represented above proceeds via the mechanism represented by the two elementary steps shown below. Step 1, Step 2. Notice the one I highlighted. That is the slow step. That is the rate determining step. So, part A here says, step 1 of the proposed mechanism involves the collision between a nitrogen dioxide and fluorine molecules. This step is slow, even though such collisions occur very frequently in a mixture of nitrogen dioxide and fluorine gas. Consider a specific collision between a molecule of nitrogen dioxide and a molecule of fluorine. One factor that affects whether the collision will result in a reaction is the magnitude of the collision energy. Explain. Hopefully that triggers a response in your head that you are dealing with activation energy, okay? And that is what hopefully you're thinking. And so we see here a collision of molecules must have enough energy to overcome the activation energy barrier of the reaction. And so that's what they were trying to hint at there. One factor, if it has the magnitude of energy, think of that energy hill, the energy barrier that must be overcome. Then, identify and explain one other factor that affects whether the collision will result in a reaction. So if you remember, not only do the molecules have to collide, they have to do so in the right orientation. Otherwise, they'll just simply bounce apart. If they don't have enough energy, if they're not correctly oriented, it'll be an unfruitful collision. And so that's what they were hoping to get out of you for the second part. The molecules must also have the correct orientation. In order for that transition state to be made, there's a specific spots on the molecule that needs to be the targeted collision area. Now, if you say they must have the correct orientation in order to create the transition state or the activated complex, that should be good. But, mentioning that there's specific sites, that can totally help as well. And now it says, consider the following potential rate laws for the reaction. Circle the rate law that is consistent with the mechanism proposed. And I just brought it down here again. And remember, our first step is slow. So hopefully, you see that the rate law matches the slow step. There's just one nitrogen dioxide molecule and one fluorine molecule. So rate equals K, concentration NO2, concentration F2. Yes, the overall reaction had a 2 in front of the NO2, but it only matters what our slow step is when we write our rate law. And explain your choice, because the rate law matches the slow step and the coefficients of its reactant molecules. So the coefficients in the rate determining step, the slow step, is what gives us our rate law. Alright, that was a pretty simple one, so hopefully you remembered all this lovely goodness, and I'll see you soon.